Hi everyone. Hi, thank you for coming to my session. So for the next 10 years of LINT, I'm going to explain how to repay or overcome the technical debts. So this is about the initiative of the LINT task force. I'm Nakamura. This is today's agenda. First, I would like to explain the background of our project. Next, the event delivery core for the line messaging service. And, of course, there are so many issues, and out of them, so what kind of the issues that the LINT project is now working on? So I would like to explain two topics. First, the background. Originally, LINT's messaging service was launched 8 years ago as a messaging app for mobile devices. Actually, at that time, the company had provided lots of services, so the LINT messaging service was one of these services. We originally targeted approximately 1 million users, and of course, this is a mobile, therefore supporting only the Android and iPhone. And on the backside, of course, for the messaging service, we had several servers, only several or a dozen of the servers as a cluster. At that time, we had a mission as engineers to stabilize the operation. Even though at that time the number of the users had been increasing, therefore we had to avoid any outage of the service. So avoiding that, and we would like to provide service in a very stable way. That was initial phase, but of course 8 years have already passed since service launch. It is LINT Messenger app. It's not just a message service, but it's evolved into a platform supporting iPhone, Android, but also desktop, Chrome, iPad, or even Apple Watch. So we are supporting these devices, and the number of the users is actually 200 times greater than we expected. On the back-end side, of course, there are so many servers. So 100 or 1,000 clusters we have. Originally, as I mentioned, we were the messaging service, but now, of course, we are operating the family-related services. Also, our platform is connected to the second or third-party services using API. Considering such situation, we were originally aiming for the stable service provision, but now we are focusing on the reliability and flexibility as a platform. However, as I said, LINT messaging service was just one of the services that started 8 years ago. So there are lots of technical debts. Some of you think that technical perspective, LINT messaging service is perfectly to collect a complete service, but this is a misunderstanding. Because you would think so, because nowadays there is no such big service outage. That could be a good reason for you to misunderstand that LINT is complete. But it's actually, every day we are facing lots of the debts. From the reliability perspective, sometimes the LINT operates a little bit different from what user expected. No, it's not 100% secured. For example, you might have that kind of experiences, even though you have already read the message, but still there was a batch as the unread. Or you would receive the message from a friend that you had already blocked. So there are these cases or the issues we have already registered. The reason why these occurred, this is because of a system or some bugs related to the codes. So because LINT is very dependent on the various systems or issues, therefore this issue could be the carrier side or the OS platform side. As I said, this issue could be ascribed to the technical debts inside. Of course, we would like to resolve these issues. But the resiliency, so how to recover, this is another point we have to improve. So as I said, the unread batch remains. Actually, when the user uses further, then probably that batch will be vanished. So that will be not so big issue. However, if there is an inconsistency of the data stored in server side and client side, in that case, to solve that issue, user has to do something, or sometimes the issue cannot be solved for perpetuity. Then for those cases, because actually the engineers work on the process and batch processing to solve these issues several times a year. So we are taking the very step-by-step efforts to maintain the current situation or level of service. Yes, reliability is very important, but also as a platform, the flexibility is another point we have to put in an emphasis. Originally, the LINE Messenger app would be used by the user to send the messages, but now that we are supporting a bot, for example, in case of a bot, probably the bot's friends will be receiving the messages and the bot will send or the broadcast lots of messages. But we are using the same mechanism. But also the financial services or wallets, we are working in the various type of the services. Therefore, the importance of a single message is more important. But because previously the user would just say, "Oh, hello," or "Good morning" to user, but probably now you would receive the notification message about the purchase history. If you don't receive that kind of notification or you receive the double same messages, there would be bigger impacts. And also there was a standing or the long-lasting request that actually the user can use one account on smartphone, or that you cannot log in on the two more PC versions, or user cannot have the private and business account in the same device. The reason why this is not supported because of the technical debts. And if we somehow resolve some part of this, then we will be facing another debt. Therefore, we cannot meet these results. But to resolve them, of course, our engineers working very, very hard every day. They are not because of the very brand new issues, but actually these issues or debts are known issues that the developers are very aware of. So these issues could be solved on a daily basis. However, some of these known issues are very large issues that could impact many things. This is not about a technical perspective, but if you work on this one, that is required lots of cooperation from the various departments or teams. Therefore, only one single developer cannot solve them. So, roughly speaking, server side and the client side, this is the division of the department. On the client side, there is the Android team and the iPhone team or the desktop side team. And the server side, yes, we have different teams by component: backend server, storage server, front-end server. So there are different teams even in the department. Because of such differences, each team has a different priority. Yes, we are working very hard. But sometimes there is not so many big collaborative work with the different departments or teams. Of course, we tried, but they did not work very well because always we have been received much high priority works or urgent tasks. In order to solve such organizational tasks, we created the task force LINT in this year. LINT member includes lots of people from various departments. So for the next 10 years of LINE, what could hinder the growth of LINE as a platform? We have collected lots of issues and pick up some specific issues that are highly dependent or they could have the big impact on other areas. So we picked up these issues. Yes, the list of the issues is quite long, but of course, because of time interest, we are now focusing on these 4 issues for this year. Each topic requires approximately more than 1 hour to explain in detail. Because of time interest, I'm going to talk about only 1 and 2. Before diving into the detailed topics, I would like to explain what is Event Delivery Core at LINE Messenger app. This explains the main components of the LINE's Event Delivery Core. On the left-hand side in green, this is your client's application, and via the L4 label balancer to be connected to LEGY. LEGY plays a role as a reverse proxy for the remote request routine for the backend server. There are various backend servers, but one of the most biggest one is the Talk server. This server is actually connecting to the Regis and the HBase, the storage servers, and returning to the client service. And also the talk server is connected to the other servers using the Thrift API. This is the main component of event delivery core. Then at line, event is described as operation. So operation is actually one structure defined on Thrift. Let's take a look. There is a revision with an operation. The revision operation is actually issued per user account and numbering from 1 to n to n. Second one, op type. Such as the message type, group type, or contact. So everything that described as enum. And the third one, most important part, payload. It contains object or the contents of a message or other type of ID, such as message ID or user ID of receiver or chat ID. So they are all included in a payload. Using this operation, we are synchronizing the data. So operation is proceeded from number 1 to 3 and is stored in the server side. Then there is a various type of the client side. So by type of the clients, the different type of operation will be fetched from the server. So by using this operation, yes, we are making the LINT delivery. Let's think about when you send or receive a message. So here, the send message. When you send a message, send message operation will be issued for sender. And for receiver, receive message operation will be issued for receiver. Then when you receive the receive message operation, then you can read that message. So this is the case when you send in a message. If you read a message, so this is the read mark or kidoku in Japanese. If you read that message, yes, there is a different operation for the sender and the receiver. So the receiver, actually, they receive the two type of the operations. So if two, then the sender can see, oh, there are two users have already read that message. This is the case for the receiving or sender message, but also for the contact. Let's say if you change your profile, then your follower will be given operation so that the data will be synced. And also the grouping, if you change the icon or profile of the group, then you and the member of that group will be receiving such operation to be synced. So here, fetch operation API. This is an API to fetch such operation. This is a very, very commonly used API on the LINT platform. So using the revision and the count at the client side adds a parameter, offset parameter as a pagination. Let's say, there is operation from 1 to 100, then if you set local revision from 1 and count 100, then the operation will be the process one by one. And if you change rev to 101, then the remaining will be fetched. When it exceeds the total value, then the client side and the server side are synced. This is the basic mechanism of LINT. So I would like this would be a little bit off of the topic, but I would like to talk about LEGY. This is a front-end server between the client side and the server side. Originally in 2012, we created LEGY as a gateway server. Back then, Google proposed a speedy protocol to draft. But we thought this is very good for the multiplexing. Therefore, we used this and created LEGY. The request and routing or the connection management are the role of the LEGY. But at the backend side, the HTTP is used for communication. So the HTTP at the backend side and the speed is also used. Therefore, LEGY is playing a role to converting these two types of protocols. As I said, LEGY was developed by ourselves. Therefore, we put lots of the optimization for the messaging service users. The detail has been already provided on the previous engineering's blog post or conference, so if you're interested, please read them. But in order to reduce the round-trip time to make more faster to send a message, or also the saved amount of the data consumption. And also the original message service was aiming for the mobiles. Therefore, we've optimized these things. This is not only confined to the line, but we considered also the mobile carrier or telecommunication and to support, to reduce the resource consumption of the 200 million units. I believe that this is very, very eco-friendly even for the global, not only for the users. So the LEGY using the dispatch operation, as I said, revision 1 to 100, then the LEGY will call to the talk server using the fetch operations, and the talk server will retrieve the designated data and retain it via LEGY to client server. And the speedy between the client and LEGY, and the HTTP between LEGY and the talk server. So LEGY is converting this protocol between speedy and HTTP. But this is the case when there is a data on the talk server, but also there is some cases that there is no data. For that purpose, we are using the long polling mechanism. This is a little bit different from the previous diagram. When you calling to the talk server, there was no data to be fetched. In that case, the talk server retains a true or false, no content. Then LEGY does not return to client. This is a polling list. Therefore, after a while, if there was a new operation on a talk server, then talk server publishes that new operation to LEGY to wake up LEGY again. Then LEGY retry that process. By taking this approach, we can save the unnecessary connections between client side and LEGY. This is very contributing to save the battery on the mobile devices. So I just explained event record. From now on, I'm now explaining the epics at LINT, how we are solving these issues. Yes. LEGY has two main issues that I explained. First, we are not using the standard protocol that was created based on the speedy. So it was already included in the HTTP2 as a standard, but we are using the internally developed protocol. And also we are using the polling style approach to get the data. So there are still the wasteful the requests within servers. We are not trying to solve these two issues. First, regarding speedy, speedy was already included on the HTTP2 as a standard. As a result, there is no pure speedy-based stable client library. Therefore, we have to develop or maintain by ourselves. So it could be easily to become the legacy code, and there is no good documentation. So this is kind of a hurdle for the new joiners. And of course, we have to maintain by each device, so it requires more and more cost. This is not only about for the client side, but also we need a maintenance on the LEGY or the LEGY side. It requires lots of money and efforts. But this could cause a very critical bug. For example, the specify the same revision and causing the infinite loop. That we experience that kind of a critical issue. Therefore, we would like to migrate it to the standard HTTP base. Of course, if we use a standard base, then the client side can be supported, such as an NS URL session for iOS and HTTP for Android. Also, the OS native functionality could be also utilized, such as MPTCP or TLS 1.3. These abundant server features could be easily used after if we migrated them to the HTTP2. Also, within the LEGY, we have optimized various parts, and this part could be easily replaced with the standard methods, such as header cache to reduce the cache. The HTTP2 has a header compression, so we can use that for the encryption purpose. So in order to reduce the round-trip time, the TLS 1.3 round-trip time, our data can be used. And that requires no performance regulation, and we can migrate to the standard methods. This is the kind of approach we are taking. But of course, if we suddenly change the protocol for the mobile message services, there would be the very risky. Let's say that if the app version 2 uses HTTP2 from SBD1 on the version 1, and if there was a big issue on the version 2, then user would not be able to use our service. That is a big problem. In that case, probably we have to hotfix the app and get the approval from the Apple. So it could require lots of time and efforts to let users further use our services. But this is not our approach. As an alternative way, from the version 2, that we create an abstract layer which can compatible with both speedy and HTTP2. By doing that, so using the LEGY's connections, the abstract layer can choose if the connection info is based on speedy, then speedy will be used, and vice versa. So the HTTP2 for HTTP2. If there is an inhibition and the version 2, the server side can easily control this situation to the back to the previous version. So we have been always taking into consideration the risk for migration. The second issue related to LEGY is the polling, which I mentioned. Even with the longer polling, yes, there are lots of the fetch operation requests within the server, and actually the empty response account for 33% of all requests, so they are all wasteful. So by solving this one, as I mentioned, longer polling or the operation is very, very commonly used. Therefore, if we can resolve this one, we can reduce the number of servers. As I mentioned, we will be migrating to the HTTP2, so probably we will be using the server push of HTTP2. This is a push style. Therefore, the push will be issued only when the talk server has data. So that's we will be able to reduce number of the wasteful connections, the communication. So this is all about the first epic. So we are now migrating from the speedy to HTTP2 and also changing from polling to the push style. This is now we are working on.
Now I will introduce how we enhanced our event delivery mechanism. Fetch operation, there were some major issues. For line accounts that have been actively using, fetch operation is no problem. However, for devices that you haven't used line for a while, fetch operation can be quite inefficient because operations are fetched sequentially from revision 1. If the user uses the line app often, then it's very time-consuming to sync. The server side must store the massive amount of operation for each of these devices to use the service, so this translates to cost. The old operation are indexed in HBase, and that adds up to 226 terabytes. And we have an additional 3 terabytes every month. The usage rate of these old operations, all of these old operations are indexed in HBase. So there is cost involved. And if you see the usage rate of this old operation, it's 0.005%. That is approximately only 10,000 users. So you can see, compared to the cost, the number of requests is very low, which makes it very cost inefficient. The other issue was because fetch operation updates incrementally. When there is one operation missing, then it will look very odd to the client side. So if you lose one operation, for instance, adding to a group, then if the client side or the server side loses that operation, then on the client side, you will be receiving messages for groups that you haven't added to. So we need to manage this per device, and these are some technical debts that we have. So we wanted to come with a mechanism to recover these more systematically and to recover the inconsistency between the client and server. And also because we're working with mobile devices, it's very difficult to see or visualize how much inconsistencies there are between the client and server. And we also have a project to visualize these inconsistencies. So I would like to show you a demo or a video. So, for instance, Brown, who hasn't used LINE app for a while, he starts up his app and wants to chat with Coney. So you see Coney in the chat list, on the talk list, but what happens when you launch the LINE app? What is happening now? So where is Coney? He goes ups and down. So something is happening in the app. So fetch operation is going on. So the fetch operations will fetch 100 at a time to sync. And the user can't do anything about this until all the status is synced. So therefore, the user has to wait until all the operations are completed. For users who use LINE often run into this problem. So developers may think that we can speed this up. But because I told you that this is updated sequentially, maybe the solution is to do parallel progress. Or maybe you could just fetch the latest information from the server. However, with the current fetch mechanism, this is not possible because each fetch is done through division. And there are some dependencies for the fetch operation. For instance, you need to join the group before you receive the message from the group. So if we don't follow this algorithm or logic, it will look very odd to the users. So, for instance, if you use LINE on multiple iPhones, then this problem will be more evident to the users, and this is why we cannot provide this service. So we are trying to resolve this issue. So we have come up with a different mechanism to sync data. So we store data by categories. For instance, adding, reading messages, adding friends. These are stored in the operation storage and each in another storage. So users who use LINE often use the operation storage. And for other cases, you use the Snapshot API. And we have two kinds of ways where client and server can be synced. By using this Snapshot API, we are trying to add 3 sync mechanisms. For inactive devices who haven't used LINT for a while, we have a FullSync mechanism. To cover partial data loss, we have 2 types of repair mechanism, auto repair and manual repair. So manual repair is one of the features we plan to offer in the LINE app, where from the help page, users can manually fix the inconsistencies themselves. So this is like the final frontier, where the users can manually repair on his own. We did not have this often. We did not have this in the past. We had to wait for the user to report to us through the customer service until we can fix this. So let me go into the FullSync mechanism. So under certain client-server conditions, instead of fetch operation, it triggers an app to call Snapshot APIs by category to do a batch sync. So I explained about fetch operation API, but we added a new API called sync API. It takes the last revision that the client has And based on various conditions on the talk server, it decides whether it does a fetch operation or full sync and returns the value. For users who use LINT often, it will go through fetch operation and the results will be returned. But for clients that have not used LINT recently, it will go through a full sync. So there are many cases. Some people just want the latest 10 messages. Some people only want the social graph. And there are many requirements that we can cover with this full sync mechanism. Let me cite you some examples. So for active users who have used LINT, so if they have like 100 or 10 or 100 unread messages, it can be synced with the server's latest revision by calling the API maybe once or twice. On the other hand, triggering the full sync is based on various server conditions. Number one is revision gap. This is for inactive users. The server revision is N, and the client's revision is, there's a huge gap between the client and server revisions. In this way, you need to call maybe the fetch operation API 1,000 times. So in this case, we will trigger a full sync. Number two is revision hole. Due to server internal issues, if you have any data lost, we use a revision hole. There are some rare cases where this can happen. So with a fetch operation, we cannot sync the data, and therefore we halt full fetch operation and trigger full sync in order to sync the client and server. So these are conditions on the servers. There are also conditions on the client as well. Number three is initialization. Is using the LINT app for the first time on a new device. In this case, you need to sync data from revision 1, and it takes the most time. You don't know how many times you need to call the API. So in this case, we also use full sync. Number four is local database corruption. For instance, on an iPhone, a particular version, you cannot read the SQWrite, and then the local database may be corrupt. Because this is an incremental way to sync, and because the local data is no longer there for us to do a complete sync, we disregard the local data and do a full sync. So this is the full sync flow based on the revision gap. The client revision 100 and server is 100,100. Because the gap is very huge, it will trigger a full sync. And then we will hand them the latest server revision at this point. The client was triggered a full sync, so then it will call a Snapshot API. If it's a message, they will take a batch sync of the message back. For social graph, they will get the latest revision from the social graph storage. And then we can do this with extremely high throughput. And we can also optimize by taking the latest data as well. But this progress does take time, so the revision may progress while we are doing this batch sync. So after the full sync is completed in the Snapshot API, we will bump up the client local version to 1,100, and then we call the sync API again. Then the revision gap is only 100 at this point. So we take the normal fetch operation, and the sync will be completed. So we combine fetch operation and Snapshot API in order to more efficiently sync between client and server. So next is our repair mechanism. So syncing data is challenging because we have more than 200 million devices. It is very challenging to maintain 100% consistency. Of course, we have some unforeseen mistakes or errors, codes, where data can be corrupted very easily. In the LINT project, instead of enhancing this, we wanted to ensure resiliency so that we can recover the data when this problem occurs. Until now, we had to wait for customer service to report the problem and use admin tools to fix it. But now we have a more systematic approach to recover data. And so that ultimately server and client data are synced. So this is the mechanism. We have an auto repair mechanism. So what is auto repair? So the client and the server does a periodic exchange of their partial data, and when we find any inconsistencies, they will repair each other. So line data size is very different based on every category. For like profile settings is a fixed data, which is we only have one profile per device. There are data for n amount, like numbers of groups or friends, or for a number of people in a specific group that can have data with higher complexity. So fetching all of these data from the server every time can be costly. So, and plus, we have no idea how much inconsistency there is between server and client. So it does not make sense to put in cost for something that we're not sure of. So we use a digest version of the data and periodically sync. And based on the volume of the data, we can control each cycle or frequency of syncing. For instance, for fixed data log, we sync them daily. For data with n amount, we sync on a weekly basis. So here is an actual example. So this is recovering friends. Right now, all the information are synced. Server and client both have Brown and Connie synced as friends. At one point, and a different client, Brown blocks, a person blocks Coney. But due to server internal errors or other issues, this was not synced. And we can add new contacts. The contact social graph data can have several states. And so multiple states can be updated at the same time if they relate to the client in the wrong order. The server and client data can become inconsistent. And so we can use frequent auto repairs, periodic auto repairs to repair this automatically. For this periodic API, we exchange data digest for the number of clients or number of friends. The number 2 friends, there is 0 friends blocked, and number of recommendation is 1. So on the server side, it should have the same number. So we compare the data. If there are any inconsistencies, then we use Snapshot API to do a full sync. So we also have no idea how inconsistent the server and client side is. So we also send a report result to monitoring for stats and analysis. Finally, as in FullSync, the client calls the contact Snapshot API and uses the latest snapshot to repair. So we have a new Snapshot API. And on top of fetch operation, we have another mechanism called FullSync. For inactive users, we use FullSync. To recover partial data loss, we introduce auto repair and manual repair. With this, we can sync between client and server more efficiently and resolve inconsistency that occur at the same time. So let's summarize today's presentation. So we have services used by 200 million users, and we are faced with immense challenges to provide reliable and flexible platform, which is difficult to resolve with under one team. So this is why we have the LINT team as an organization project made out of multiple teams to resolve these issues. So I shared with you only 2 issues that we are working on now, but this is a full list of more issues that we would like to resolve. LINT is a project for the LINE's next 10 years, but I'm excited to work with many different teams to resolve these issues within the next decade. This concludes my presentation. Thank you very much.